So far I've shown you how you can digitally sign messages and thereby show that you are the right owner of a piece of a Bitcoin or of a digital item. That's very useful and is a critical part of blockchain technology, but it is not enough. In order for this to work, you have to actually solve the double spending problem. Now, what's the double spending problem? Well, we have these two characters here. Sue wants to make a deal with Bob. For instance, say they agree that they are exchanging a digital item. So what Sue promises is to say, hey, I'm going to send you these Bitcoins and I'm going to go use the Bitcoin miners network. So she then sends a digital signature and a digital signed transactions to Bob that Bob can see. He can also check it, and then the miners can validate that transaction. Is that enough? Well, no, the answer is that's not enough. And here's why. At the same time, when she's talking to Bob, what she could also do is she could talk to Charles, make a deal with Charles, and try to spend exactly the same Bitcoin and send a transaction at exactly the same time to the miners. They would also be able to validate that transaction in terms of that the signature matches, but you could, in fact, spend the same money twice. What needs to happen is that the miners put a record on the database and thereby ensure that the particular amount can only be spent once. What matters here is indeed that the order of transactions could change, right? So for instance, Bob cannot be sure that Alice has not put, two orders to get in together and that his order will come up first and therefore is the only one that will be accepted. He cannot be sure just because Alice has digitally signed the message that she will not cancel it in the latest point. So what really is important is that Bob has the ability to check against the database that that the contract has actually been initiated, that the money has been transferred, and that he has proof that this works. And for that, you need the database to work. So that brings me to a critical feature of how this database can actually work. Now, I want you to recall that a blockchain essentially is distributed so that information is kept at many different points. Now, these nodes where this information is kept do not trust one another. And so they have to find a way how they can coordinate their activities and how they can coordinate the updating of the database. In order for you to understand how that works, so just as a quick recap, so public keys ensures that you cannot be impersonated. Hashing links the information, but we still need to find out a way of how to figure out how the network can agree. So how does this work? Well, in order to explain the problem that we're facing, let me run you through the basic problem of the so-called Byzantine generals. So what we have is that a group of generals want to attack a city. Now, the only way how they can defeat the city is if they have a coordinated attack. And the question is, how can they coordinate the attack? If they have a small number of generals attack the city, then the city will be able to fend them off and actually, decisively defeat them. Because you need the entire network or the entire network of generals to do the same thing at the same time. So the question is, how can they coordinate their attack? Now, what they will do, of course, is that they will send messages to one another, but they have to be sure that they cannot be impersonated. So imagine you have one city gets captured and one messenger gets captured by the city, and the city just sends a completely different message. They don't have to fake the message, they don't have to break the message. All that they have to do is send a different message and thereby destroy the coordination amongst the generals. So they need a coordination device. They need to have a mechanism that allows them to trust that the other side actually is the one that sent the message beyond the digital signatures that are being sent to them and that are being posted. So, obviously what you want to do is you want to have a situation where messages are easy to check, where they're very hard to forge, and where you can send many messages. So how's that going to work? Well, this is where the proof of work protocol comes in. So you have several people, they're going to send transactions to the miners validate them. And what they then do is they put them together, they stack them, they create a hash of these transactions. And if this hash has this is the critical part, has certain special properties, then it's going to be added to the chain. Now, most likely it will not have special properties. The special property is the coordination device that I talked about in class before. This is in the Bitcoin blockchain is the number of leading zeros. Unless you have the number of leading zeros, it will not be accepted by the network. So how do you create the leading zeros? Well, you just basically add nonsensical information, a nonce, to the hash of the transaction, and then you do another hash. And if this another hash has the special properties of starting with a certain number of leading zeros, then the network will accept the transaction, this block, as a new addition. Or if you want, then the Byzantine generals will accept, if they receive a message which starts with the leading zeros, then we will accept it as a valid message. Now, why is this, what is really going on here? Why is this important, and how does this really work? Now, what happens with the proof of work is you need to create this leading zeros. Okay, that's your coordination device. Getting these leading zeros is actually pretty difficult. It's costly and it's time consuming. So if you're a forger, what you have to do is you have to work really hard to change the message. Now, the message is also sent to many messages simultaneously. There's some strength in numbers, so the forger needs to capture many messages. And unless there are too many forgers around there, so there's actually a math result out there which says, which limits the number of faulty, of cheating people or forged messages to a certain amount, then you can trust the particular message that you receive. That's essentially how it works.